Great. Okay, so today we're going to quickly go over some phenomenon around solar cooking. We'll talk about sun and seasons, light, solar cooking design criteria and constraints. We'll look at some of the ovens that are out there on the market kind of from commercial standpoint. And then we'll talk about building our own oven and then running this experiment. And really, with the end in mind, what we're going to end up doing here is people have already been playing with their sensor board and their OLED display. But what we have is a sketch setup. And on this, we have an ambient temperature sensor. And with that ambient temperature sensor, we can log that data here to a display. And that'll show the maximum temperature and the current temperature. And what we can do is kind of have this be a fun event for the students where they can actually see who can maybe design the best solar oven that's going to get to a certain temperature the fastest. So I'll go to my slides here. So first, let's talk a little bit about the phenomenon that can be associated with solar cooking. So one of the things we have is about 3 billion people actually depend on wood to cook. And a lot of times these are inefficient ovens, and they end up with a lot of issues with having smoke in contained rooms, and this can cause a lot of lung issues and really affects children and the elderly. Here's a couple other examples of just people cooking with fires and just continually having smoke in their lives. And then also, we have all that, the wood burning stove. So we also have people that spend a lot of time and energy gathering wood. And also, like, this takes, a lot of time. And it also can take, for some families, this might be like a third of what they spend in order to gather firewood. So it's like, here's kind of the other end of the spectrum is looking at, this is out in California, Southern California, where they have a huge solar farm here where we have reflective solar energy. And so this is the idea of, we have all this energy hitting Earth, and I think there's an opportunity, and this could be some of the phenomenon you could talk about with students. And then also kind of this one here too, if you think of like, you get a black car and you roll up all the windows, and maybe you're in Arizona and you have your pet inside of there, you really have a really big solar oven. And so I think this is a kind of a phenomenon that you could also talk about before or after, and and maybe you talk about dogs, but this obviously relates to all mammals. Okay, I want to go over some of the things that I think are good anchors to chat about when we talk about the science around this. So the two factors that we really talk about with like a solar oven is going to be the altitude of the sun, and so that's the height of the sun over the horizon, and then the azimuth, and that's going to be where it is on a compass. So these are two variables that you can talk about with your students. And what I'd like to do is also just remind people that Wolfram Alpha has a really cool interface for this. And if you wanted to see like what is the altitude of the sun at a zip code, and you could just type this into a Wolfram Alpha search, and it gives you a bunch of data, but one of them is it shows you really this kind of cool progression, the sun over the horizon. So you can see here, and then it gives you some cool stats, like the maximum altitude for that day. And then you also have kind of like when you rise and sunset. But you can also do some kind of interesting things where you can actually put in like a time of year. So you can look at, wow, okay, the sun is getting maximum altitude but if we look at that maybe during the summer equinox and kind of getting an understanding of what that difference is. You can also put in different locations. So might be interesting to see what the altitude of the sun is in your current location, and then look somewhere north, like in Anchorage, Alaska, or what's it like on the southern hemisphere, and really get an idea of Earth tilt and some of this framework that you can start showing students. So I recommend getting out and looking at where you think the sun is, and then maybe having some tools to get out there and track and see if your estimations were correct. Couple quick apps that are kind of fun is on the iPhone. There's a couple apps, but this one is nice and free. Lumas for the iPhone, and what it'll do is it'll do like augmented reality over a position and show you where the sun is over time. And this is this could be fun for maybe if you're taking a picture for the family, you want to know where to set people up, but for solar cooking, this is where you can know where to aim your oven. And then also, like if you were looking at that with the Azimuth, you can actually look at that and pull out a compass. All Androids and iPhones have compasses built in. So one of the things that, right now we have like 2 feet of snow in our backyard, and it's like, well, solar cooking, can you do it? Well, at first, my mental model of this was actually wrong. Was like, I knew how like, when we're in the summer, we get more direct hit, and then that projects that sun over a smaller area, and then when we're here in the winter, it's over a larger area. But this is really not the biggest factor on solar cooking, because it really, if you're in this like December sun rays here and they're spread out longer, it's really the angle in which you're collecting that sun from your reflector is really the big factor. And then you might also have, though, obviously, it might be just colder out and you have ambient temperature that you might be fighting with. But it's totally possible to have a solar cooker out in the snow and actually get good heat. You have to maybe have a good design that has good insulation. Okay, a couple of things to chat about I think with the students. It's really important, and this moves right into the design perspective of your event. Is when we have this sun, it's coming and it's moving from one medium to the other. In this case, it's moving from the air, and then it's hitting either a reflector or it's hitting some other type of medium. In this case, it has 3 things that it can do. It can be reflected, it can be transmitted, or it can be absorbed. And these are really the 3 things that can happen, and we'll continually, I think these are good things to continue to talk about when we talk about our design, and they move right into when we look at the design criteria. I have I'll share these slides here, and down at the bottom there's a really good video that really talks about those 3 factors. So when we look at the design criteria that kind of really correlates here, we have a reflector, transmitter, absorber, and insulator. So these are the 4 things that we're really thinking about when we're designing our oven and when we're looking at kind of the design criteria for our oven. Okay, so what I'm going to do is kind of move into some of these off-the-shelf different types of ovens, and let's look at these just quickly one more time: reflector, transmitter, absorber, and insulator. So, and we'll talk about these and kind of look at them in the design. I think this is something you can do with your students also. So in this case, what we have is this is a box cooker. This is actually a unit that I have here, and what you have is reflectors. It has a box and a piece of glass over the top, and what it does is it reflects the light inside of the box, so you have that reflection, and then the glass is the transmitter in this case. And then inside the box is painted black, which is an absorber. One thing to note is we also have a lesson on light absorption. This might be a good entry into this lesson. Another type of solar cooker we have vacuum tubes. So these are vacuum tubes, and they slide the food inside of them, and it's kind of like creates like a super greenhouse effect inside of this vacuum tube, and has special coating here to collect energy. These are often used also for, you'll see these for heating water on roofs. And then we have the Parabolic. So these are really cool. This is just a big reflective dish, and then it concentrates the heat into one point here, and you can put a vessel on top and heat it from below. And then we have the pizza box. So this will be some of the technology that we'll be working with. We have a good guide in here, and we'll spend a little bit of time on it, but I want to I think there's good directions here, and I think it's just a good engineering event, and I think everybody will do good with this guide that we have here. So if we look at this one here, okay, let's look at it from our model here. So we have our reflector here. So this is aluminum foil that's reflecting down into a box. Over the box, we have like saran wrap, and that's the transmitter. So the light's reflected off of here, transmits through there. And then inside the box, you want to get it dark. So you can put like black construction paper, or it could be painted inside. and that's what absorbs the heat. And then from the insulation side, you have that that cover on there that's transmitting through. That's keeping some of the heat inside, and then also you pack some like newspaper around there too as an insulator. So that's kind of how that works. I also wanted to show another cooker. This is the Cool Kit, and this one's used through, I know, Africa quite a bit for different types of projects, and they'll use them for places for, they're great for like pasteurizing water, where you might not have access to clean water, or for cooking a rice dish like a slow cooker. And if we look at it here, we have reflection. The transmitter is actually like an oven bake bag, and then inside we have a dark object for absorption. And there's actually, I have a link there, and you can actually build one of these also. So they have like a full diagram you can do to, if you had a large printer, or you wanted to do, if you had time to do some drafting type project, you could do this. But you can also print this out, and I think it's like 24 different sheets of paper, and they all line up together and tile together, and you can put that on cardboard, put aluminum foil on, and it folds into a nice little oven. Also, I have a link here, so there's a real good section that has, I don't know, there might be 100 different types of designs for solar ovens. So I think it's great to, if you have the time, to have, you know, students maybe even come up and look at some designs that they'd like to do and have competing designs, if you had the luxury of some of that time. Okay, so let's go ahead and I guess before we do that, I have some solar ovens here. I can give you a quick view of these. Let me go ahead and do, just gonna do share off. Then you can see me. Can you, Sunny, how do I look? Can you guys see full screen here?
Not yet. I think we're still viewing your screen, so.
Okay. Well, let me get that. Okay. Do you guys see my screen? See my
Yeah, we're still seeing your screen. But I think if everybody just clicks on your
my
thing,
video?
yeah, on your video, then you should be able to enlarge it. So
I'm going to try spotlight video. How about that?
I think that does it on your end, but not on our end.
Okay.
So, yeah.
I'm going to go ahead and skip that. I have a few ovens here, but we'll get right into running the experiment. I'm going to go back in. I'm going to share my screen. Okay. Does everybody see my screen?
Yeah,
okay.
We can see it.
Perfect. Okay, so I'm going to move right into our lesson here. So this is kind of a, if you can always get to this by going to Because Learning, search other lessons, and then there it's called Solar Ovens. And when we look at it here, there's some guide here that talks about how to build that oven, and has a link to a great guide. We have our standard wiring diagram here. So in this case, a Arduino just plugged in, and all we need is a sensor board. For this one, we will have the OLED. You just plug that in also. And we actually have this guide set up so you have two different options for this. So you can actually, if possibly you have an older kit, or if you prefer to, you can use this computer data collection method. And I can show you that right here. Let's see, we'll do that. So down here you have a selection for kind of like choose your adventure. In this case, we'll show what it's like for the computer side. I'll go down and I'm going to hit run. It's like my port. And so what I'm doing right now, I'm flashing that program on my Arduino, and it says successful. And then I can go down into collecting the Arduino data. So in this case, we get the ambient temperature, and there's also infrared and luminosity on there that can be kind of interesting to look at from inside of a solar oven. And then from here, you can actually go in, you can start recording the data set and get a nice temperature curve. And so this is a method that you can use. Let's go up and look at the other method here, which would be with the OLED display. So you just select that down below. And so with the wiring diagram, we will have an OLED in there. I'll change that. We'll go down and flash this. Okay. So I'm flashing a new program on there, and you can always see that by these two lights right next to the USB. You can see these two lights flashing away, and that's the RX and TX, and that means there's data coming off there. Once that ends, then generally, hopefully we'll see like a nice message saying it's successful. And at this time, if you guys can see my video, we are capturing data. It's kind of hard to see that there. If I scroll up here, so you can see in the lesson, I think maybe in the picture we can see that here. So on this display, what we have is a max setting, and then we have the current temp. And right now it's ambient temperature, so it's not super active, so this is a bar graph, but over time you would kind of see this kind of build up into a bar graph. And the way that you can scaffold this is you really build your solar oven, and you can put your temperature gauge in there, and remember this is a good one to actually take your device and use your 9-volt battery clip. So this can be all remote. Plug in your 9-volt battery clip. I've got one here, and so you kind of have your remote unit. Okay. So now we're on battery. And what you can do is place this inside of the solar oven. Also, if you were maybe using the other method where you're going to build like that cool kit, the panel oven, what you can do is get like a mason jar. You probably want to, they talk about it in there, but you can cover your mason jar with a black material for absorption. And then you can just put your sensor board inside of that mason jar, kind of seal it up. Then you can have your OLED outside and kind of be monitoring what the temperature is inside of that device. Now, one thing I wanted to show too is on this code here, I just added this just recently, and what we can do is actually put in a alarm setting. So this will be like a threshold for when it hits this temperature or above, it will do something. So inside the program, we have an if statement, and what it does is it looks at this variable right here, and this is something you can change with your students if you'd like. Maybe inside when you're testing your project is so right now it's set for 115, and this is in Fahrenheit. There's some code in there if you wanted to change it to Celsius. That's great. And it actually does two things. So, and hopefully you guys can see my video here. If not, it's wired up here, and you can do two things. You can set this up so it'll work with the piezo buzzer or with an OLED, with an LED. And you can actually place these straight into the pins on the board. And this is totally optional, but you have the ability to go in and just plug it straight into the board, into those pins. You got to get them into the pin. But this is a way that you can actually have it go off with when it hits that alarm, it'll set off an LED, or if you want to, you can actually put in this piezo straight into the connections also. Something like that. So, and I'll have the wiring diagram on there for that, but just a simple addition, you can do that. So the way that you can set this up is you have this hooked in, and then you can have a contest and set that threshold, and then have the students get out, and when they're ready to start, everybody opens up their solar ovens and gets ready to see who can get to the threshold the highest. So I want to do a time check here and make sure I leave some time here for questions. So we only have like 7 minutes left. So I think with that, I'd like to make sure I leave some time for questions, and I'm happy to dive into this. And also, if anybody has any questions, they can post them into the community, and I'll be monitoring that, and we can get answers there too. So maybe we'll move into question and answer. And Sunday, maybe if you can help me with
Sure. We got one question so far from Becky, wondering if you can make the slides available for the
Absolutely.
group. So yeah,
Yeah.
so I told her we would share that.
Yeah.
Any other questions? Feel free to, you can either hit the unmute button to speak your question, or you're welcome to just post them in the chat and I'd be happy to read them out loud for you.
I'll add those slides to the lesson itself, and then we'll also have this webinar that when it gets recorded, we'll upload it also.
One question. So how have you seen this class or this lesson being done with a class of like many students? What's a good way to organize this?
Yeah, in the lesson, there's actually kind of a framework that you can use. Let me get back to that, which I think is effective. And what you can do is you can actually set up your groups and create teams. And you can have like an electrical engineer, a solar engineer, and scientists, and then they each have like a particular job. So you can get like these subgroups broken out, and then they all have like different components as a team to put together. So I've seen that work really effectively in the classroom. So it's a good way to kind of divide up the students, and then also there's some hands-on stuff, there's some coding and data science and all that in a job, so it can kind of be this can kind of help things move along smoothly.
Great. We have another question. Is there a temperature from Darren? Is there a temperature that we need to be careful of that may cause damage to the board or the sensor or the OLED?
Yeah, good question. So you should actually be good up to like about 180 degrees. I would recommend you don't go over 140 degrees, and maybe keep your threshold for your alarm at maybe 120 is probably good guidance. But yeah, you'll actually have a pretty hard time, I think, with a pizza related type of solar oven. I'm sure you guys do some good engineering, but we haven't seen anybody destroy anything with these yet.
Great.
Great.
And then there's a question from Jeff. If we could give a brief introduction to our backgrounds. So
Yeah,
Kevin, why don't you go first? Yeah.
Yeah, I kind of jumped right in there. Sorry about that. So it's Kevin Coco, Chief Technology Officer here at Because Learning. And my background is in computer science, and but I also work a lot with hardware and engineering lately. And yeah, and with solar cooking, it's a passion of mine that I've been doing solar cooking for years. I've done kind of the biggest thing I've done is the 15-pound turkey in a solar oven, and I've done lamb shanks, and I've used it a lot for cooking when I'm camping.
Okay, and I'm Sunny Washington, so I'm the CEO and also co-founder of Because Learning. I've spent about 16 years in the ed tech space, so I've been working. We've been working on this company now for about 4 years. So we work with hundreds of schools, kind of all over the country, and also actually international as well. I have eaten a burger off of Kevin's solar oven, so I can attest that it works and it was real tasty. And so that was really cool to see that we did that over the summer. So I really enjoyed that experience. So another question that Jeff had was, do you actually ever heat up food? Yeah. So, and then, what about, he said, I've done s'mores because all ingredients edible are uncooked are still edible. So,
Yeah, that's
so
a great one. I think, yeah, I saw that, and a lot of people are using that, or yeah, you could do like maybe a quesadilla or something like that, where you're kind of melting cheese between and I think that's a great observation, that you can eat all the raw materials, so it keeps it safe for the classroom. But yeah, I've done full, like I said, 15-pound turkey, and a common question is, how long did that take? It took 5.5 hours, and that was with a box cooker. And then recently over the summer, I actually did canning too, for like jam.
Great. Are there any other teacher resources that we have in the lesson that you can show, Kevin?
Oh, for this particular lesson?
Mm-hmm.
Yeah. So let's see here. At the bottom, we do have, there is a let's see, am I on the right one? Let's see here. There we go. There should be a lesson guide. So this is something that's available here. So a little bit of like the pre-work, something you can send home with the students to their parents, so they can ask like questions at the dinner table, maybe about their experiment and what they did with their solar oven out. And then we have inquiry guideline, and then some of the mapping here for NGSS. I also wanted to show other resources here. We have, let's see, it's light. Let's see if I can find it. Color and heat absorption. So this is a good lesson to really give the students that concept of talk a little bit more about light and understand like black is obviously a really great material if you want to absorb heat. So the inside of your oven, the outside of maybe your vessel that you're cooking in, these are all good learnings. And then I think those are, and then also one other that I could show here would be, I think it's car safety. I can spell safety. And this is around the phenomenon of car temperature safety. There we go. So this is around the phenomenon of how long does it take to get to a certain temperature in a car, and it has a whole framework for running this, and kind of around the phenomenon of you know, the danger of having children and dogs and pets and stuff like that inside of hot cars on a summer day.
Great. I think that's all the questions that we have, and we're just right on time for our end period. So thanks, Kevin, for doing this. I think a lot of us are really excited to build a solar oven, and you know, it just you know, with relatively simple materials, you can have a great experience with your class and your students. We will make the slides available. We'll also follow up with an email that has links to this, and then also a link to the recording, so you can rewatch this. And then if you have any questions, feel free to reach out to us. You can reach Kevin at becauselearning.com, or myself, Sunny, SUNNY, at becauselearning.com, and we can you know, respond to any questions, or you can post them in the community as well, and we'll make sure to monitor that as well. Anything else, Kevin, that you want to share?
You know, the one thing I wanted to show quickly too is we do have a link in that guide that does show you exactly how to build this oven, and it's a really great guide, and I think everybody will have no problem following this. And if you have any questions, just put them in the community or send me an email directly. And it's been a real pleasure, and I look forward to see what you guys engineer.
Thanks so much, everyone. We'll talk to you later.
Bye-bye.